In this class, we're going to look at a different inferential question. Okay? And as the little cartoon there says, is what we're trying to do is we're trying to get it right. We're going to try and figure out what something is, and it's something which is somewhat hidden. Okay, what am I talking about here? Okay, let me go a little bit more to the essence of the point. In hypothesis testing, we ask a question of the form always, is it true that? And then the answer is going to be yes or no, or more generally, we think so or we don't think so, right? That means that we're starting with some kind of hypothesis, which of course we call the null or the alternative hypothesis, and we're simply analyzing those hypotheses and see if the data are actually supportive of them or not. Now, in some situations, that's not exactly what we want. In some situations, the question we really want to ask is, how much is something? Okay, so we may not be so much interested in knowing if the average age of Red Deer College students is more than 17. What we may want to know is, well, how much is the average age of college students? Okay, I don't want to know if it's more or less than that because I may not have any idea of how much it is. So I can't even create a hypothesis. Okay, and notice that in some situations that is very much a realistic question to ask. How can we even ask a hypothesis testing question if we don't even know how much something is? So in that situation, we're going to do estimation. Okay. Now, what we're still going to do is we're still going to use the same procedure in terms of using sample statistics to guess at population parameters. And of course, what we're trying to do is we're trying to use the sample statistics to make an educated guess. Okay, so we're still doing inference, okay, but it's inference of a different kind. Well, let's see what kind. Now, first of all, let me tell you there are two kinds of estimations that statisticians talk about. One is what is called point estimation. Okay? Well, what does that mean? Well, it's pretty much a fancy way to say use the sample statistics directly as estimate. Okay? So in other words, you collect a sample, you compute from the sample some statistics, well, use those statistics and say, well, that's as close as I can get to the population parameter. For instance, okay, what we can do is we can use the sample mean as an estimate of the population mean. So I collect a sample of Red Deer College students, so I compute their average age or their mean age, and then I say, well, my estimate of what the mean age of Red Deer College students is this one. Okay. Actually, this is a process that we've already used before, okay? Because remember, in the past we used observed proportions to estimate probabilities, right? So what we may want to say is, well, what proportion of Red Deer College students is females? So I collect a sample, I figure out what that is, and then once I collected that sample proportion, I can say, okay, so I can use this one as my estimate of the probability that if I collect it or if I pick a random Red Deer College student, I will end up with a female. So this is something that we've done before, and it certainly can be done. I mean, it's something which it can be done, it is done, and it is quite effective, and it's basically the best you can do in a way from a sample to get a numerical value for the population value. But there is a big question here, okay? Does this ever provide the exact value? Okay, we're looking for the population mean, so the mean of the whole population. Do we ever get that value exactly just by collecting one sample? Well, as you know, probably not. There is all kinds of random variability going on with sampling, and so in general, we don't expect a sample to be as accurate as perfection. So what we want to do is we want to go a little bit deeper. And how do we take care of this lack of accuracy, of this lack of exactness, right? How inexact is our estimate? What can we say about it? And this is where the really interesting part of estimation comes in.